Hey guys, so today we are going to continue with our topic that we started, that is first law of motion, right? So we've already gone through the statement for the first law, and that is, I'll recap the statement for you. Any object tends to stay in a state of rest or uniform motion unless acted upon by some external force, which means any body which is at rest, not moving, will try to stay like that, and anyone which is moving will try to keep moving unless some other force is telling it to change. Okay, now yesterday we also spoke of this word called inertia, right? We introduced a new word, inertia. I told you it's a body's reluctance to change its state, right? Now I gave you a couple of examples for inertia, right? One of them was the coin experiment we saw. Another one is we spoke about how when we are in a bus, there's two situations where we'll experience inertia, right? So in inertia, we say there are two types of inertia. Okay, we call them, one is static inertia, the second one is dynamic inertia. Right, so to understand these is quite simple. This is just the difference of the object, right? For example, right now this ball is moving or not moving. Simple, it's not moving, right? It's on the table, the desk is stationary, ball is stationary, I am stationary, everything is stationary. By stationary I mean not moving. So rest, stationary, all of these words mean not moving. Okay, now if some force acts on this ball and tries to move it, then I'll say that this ball has some static inertia. Okay, when we say static inertia, we talk about the object being at rest. The object being at rest, which is trying to be moved by the force. Okay, since static means not moving, easily you can understand that when the object is not moving, it has static inertia, which also means not moving. Okay, the opposite for that would be for an object that is moving, right? So for example, consider this ball here. Now if I roll a ball, notice that I only push it once. After a while it will stop moving on its own. I mean, if it hadn't fallen off the desk, I'll simply expect the ball to stop moving on its own in some time, like this, right? The way you see it, this object stopped moving, but I did not use any force. Alright, we'll come to that in a bit. Dynamic inertia is the second type of inertia, right? It is when a moving object is forced to stop by some other force, kind of like how this ball stopped. Right now, these two things again, if you remember the bus example yesterday, when the bus is not moving, we are not moving, and the bus starts suddenly, we get pushed a little back, right? That is static inertia, because you are at rest and the bus is also at rest. Bus moves, you are still at rest, but you experience that pushback because you were in static inertia, because you are not moving and suddenly you are being asked to move by the bus. Okay, the opposite, dynamic inertia, is when you are moving along with the bus, but the bus stops suddenly, which is what makes you like go forward, right? Because you are moving, but you're suddenly forced to stop by the bus, which is why the body kind of tends to move forward like that. That is dynamic inertia. Very simple way to remember these two terms: static not moving, dynamic moving. Right? Now coming back to the example of this ball, I told you that I am pushing it with one force, but I am not using any force, but the object is still stopping. According to the law, we said it will stay in motion unless some force is making it stop. But which force is making the ball stop? There is a force that's making it push. It's at rest, I pushed it, it started moving. But why is it stopping? So this force is the normal forces that we have in nature. Okay, maybe we are familiar with these, right? Gravity is one force that's always acting on us, keeps us on the ground. Friction is one force that we learned about in previous classes, which helps us write, helps us walk. So all these forces are always acting on objects, right? So even for this ball, when it's moving, it stops because of the friction on the table, right? The friction of the table makes the ball go slower, and then it stops. So technically every object faces some sort of force all the time, even moving objects. Okay, so in this law, first law, will say that when a net force is not acting on the object, only then we will say that it will keep on moving. Say for example, there is no friction, no gravity, no nothing. Then if I moved the ball would keep on moving no matter what happened, right? Unless some other force. So we should mention that unless a net force. By net I mean total. Now one question that arises always is, does everybody have the same inertia? Is my inertia the same as my cat? Is my cat's inertia same as my phone? Right? Simple question to understand. Like in physics, we're just going to use an experiment to figure out. Now what experiment we'll do is I'm going to use two different objects. Okay, two objects with different mass. So over here I have this matchbox. It's a very light box, and I have this old charger of mine. Okay, I'm going to push both of these objects with the same force. Okay, I'll make sure I'm using the pen to push both of them with one hand. So since they're being pushed by the same pen and by the same hand, it means they're being pushed with the same force. One of these objects is not going to go as far as the other object. Okay, so to observe this, I hope this is clear over here, right? They're starting at the same point. 3, 2, 1. Now it's quite evident that this object didn't go far, that object went very far. Now we know that the matchbox is definitely lighter than the charger. So that tells me that the more the mass of an object, meaning the more heavy it is, the more inertia it has, the more reluctant it will be to move, right? Simple, a real life example again I can give you. Say that you need to push a cycle. Very easy, right? You just hold it and you push it, it is going to move. Now say if you have to push a bike, more difficult, right? It's simply because the object is heavy, and since the bike is not moving, it will have static inertia. That static inertia will make the object not want to move. You can try out this activity on your own at home. Take a light object, take a heavy object, push both of them with the same force, see which goes far. It will always be the light object. Okay, just make sure that both the objects have the same shape, because the shape matters, right? I can have a heavy ball which will go farther than a light square, right? That is a whole different concept altogether. All right, okay, so that's all for today. Thank you for attending, and I'll see you in the next one.